Hello and welcome to this lesson on data handling. In this lesson, we're going to have a look at how we use set notation. So before we do that, okay, this is the starter for this lesson. I'm asking you to place the numbers 1, 2, 3, 4, 5, and 6 in the correct position in this diagram here. So the numbers 1 to 6 need to be placed in the correct position in here. Okay, and as you can see here, I've got a circle which I've labeled A, and I've got a circle which I've labeled B. The circles overlap here in the middle. Okay, and A contains the even numbers from 1 to 6, and B contains the factors of 6. Okay, I'm going to give you a few moments, so pause the video and have a go at that question, and when you're ready, press play. So press pause now, please. Okay, welcome back. So we're being told here that A contains the even numbers. So what do I know about even numbers then? Well, they are multiples of 2. So they're 2, 4, and 6. So the numbers 2, 4, and 6 must be placed in the circle which has got the label A. And B contains the factors of 6. Now, what do I know about a factor? Well, a factor is a number that goes exactly into 6, but without a remainder. So 1 is a factor of 6 because it'll go into 6 without a remainder. 2 goes into 6 without a remainder. 3 goes into 6 without a remainder. 4 and 5 do not go into 6 without a remainder. And 6 goes into 6 without a remainder. So the factors of 6 are 1, 2, 3, and 6. Now, if I look carefully, I can see that in A, I've got the number 2, and 2 is also in B. So hopefully you put 2 in the middle here. And you've also got 6 that's in A and in B. So hopefully you've also put 6 in the center. What does that mean then? Well, it means from set A, the only one I haven't placed in circle A is the number 4. So hopefully you've placed that here. And then for B, the numbers 1 and 3 will be placed here. So are we done? Well, think about it. The only number that we haven't used on this diagram is the number 5. That's because 5 is not an even number, and 5 is not a factor of 6. So where does it go on this diagram? Well, it won't go in any of the circles. So hopefully you've put the number 5 somewhere on the outside of the circles, but still within the diagram. Well done if you got that correct. Okay, what is a set? Well, a set is a collection of objects which usually contain numbers. Sets are shown using curly brackets. So for example, here I've got a set that contains the numbers 1, 5, 6, 7, 8, and 24. But it can also contain non-numerical data. So this set contains modes of transport such as car, bus, bike, plane, or train. Normally, we start off with a big set that contains everything that we care about. Now, this is called a universal set and is called epsilon. Now, this is a Greek letter that we sometimes use in maths. So epsilon will be used for our set that contains everything of use to us. We can then use smaller pieces of this big set, which we call subsets. So we can break them down into everything. So if I go back to the starter question, in this starter question, my epsilon, that's not really a great, there we are, it's a better epsilon, would contain the sets 1, 2, 3, 4, 5, and 6. Okay, so that contains all our data values, and I could do a subset A. Now A contains the even numbers, so A would contain the numbers 2, 4, and 6. And B would be a different subset. It contains the factors of 6. So in here would be 1, 2, 3, and 6. Okay, so there's my whole set, all the values of interest to me in the starter question. Here's my subset A, and here's my subset B. Right, so that's a little bit about how we set up a set and a subset. So for this sort of piece of information now and introducing you some new terms, I'm going to be using the set which contains the numbers 1 to 9 for my universal set epsilon. Now, A is going to be my set of odd numbers. So that's going to be 1, 3, 5, 7, and 9. And B is going to be my set of prime numbers in epsilon in the universal set. Now, a prime number has two factors where the two factors are the numbers 1 and itself that go exactly into the number we are looking at. So here, my subset for A is 1, 3, 5, 7, 9. They're my odd numbers. And B, which are my prime numbers, are 2, 3, 5, and 7. So they're the prime numbers from this universal set. Now, this is a new bit of notation here that we use for sets. It's called A complement. Okay, so we say A complement, which means everything that's not in set A. Okay, so what is not in set A out of the numbers 1 to 9? Well, in this case, it's 2, 4, 6, and 8. Okay, and this is B complement, so that means everything not in B. So have a look at set B. And what's not in B from the universal set? Well, in this case, 1 is not in there, 4 is not in there, 6 is not in there, 8 is not in there, and neither is 9. So there's my B complement set, and there's my A complement set. Okay. Another typical piece of set notation is this here, and we say it's A union B. Okay, so the U is for union. It means anything that's in A or that's in B. Okay, so what is in A or in B? Well, we've got all of these numbers in A, and is there anything in B that is not in A? Well, we see here that the number 2 is in B. So if it's in A or B, then it contains all numbers in A or B. So that will be 1, 2, 3, 5, 7, and 9. So they're the numbers that are in either A or B. And this one here with the upside down U like an N means A intersect B. It's the intersection. Okay, so anything that's in A and is in B. So it must be in both A and B. So if we have a look now at our A and B, what's in A and in B? Well, I can see 3 is in both, and I can see 5 is in both, and I can see 7 is in both. Now they are in A and in B. So that would contain the numbers 3, 5, and 7 in that set there. Okay, what I'd like you to do now, here's your main task for the lesson. I'd take about 15 minutes. I'll go at each of these questions. So on question 1, got a universal set and 2 subsets A and B already done. I want to know what's in these sets here: A complement, B complement, A union B, A intersect B, etc. Okay, pause the video now, and when you're ready, press play to get your solutions. Okay, welcome back then. And here's the solutions for questions 1 and 2. So everything not in A was 2, 6, 10, and 14. Everything not in B was 6, 8, and 14. A union B means it's in A or in B. So that's 2, 4, 8, 10, and 12. A intersect B, so it's got to be in A and it's got to be in B. So 4 and 12 are the two numbers in both. And again, here you could see the solutions to question 2. Now, question 3 is about colors. So here's A, red and white. So everything not in there is yellow, blue, green, and pink. Everything not in B is red, green, pink, and white. Now, when we say A intersect B, what's in A and in B? If we have a look at A and B, A has got red and white, and B has got blue and yellow. So nothing's in both. So that can be written as nothing in the set. Now we do that by placing like a naught with a line through it. This means if there's nothing in the set, we would put that in between the brackets instead. For A union A complement, that's everything in A, or not in A, which is everything in the list. So everything needs to be listed. And what's in B and not in B? Well, nothing. So again, use the naught with the line through it. Well done, you've got all those questions correct. Okay, your checking question then. I'm going to ask you to pause the video and have a go. And when you're ready to check your work, please press play. Okay, welcome back then. So this time, epsilon, which we've been using for the whole set, is all the numbers from 1 to 20. That's what integers are. They're whole numbers from 1 to 20. So contains everything from 1 to 20. And the word inclusive means it includes 1 and it includes 20 as well. Okay, so quite a long list this time of numbers in here. Okay, so much larger than the lists that you had for the main task. So there's all the numbers that we can choose from. So A is a set of all even numbers, B is the set of prime numbers from this list, and C is the set of odd numbers. And we're being asked to work these out. So hopefully you came up with 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20 for your even. Set C are your odd, so these ones here. And these are your prime here for set B. Okay, so there's our 3 lists. Right, A intersect B. It's got to be in A and it's got to be in B. So what's in A and in B? Well, I can see 2. And that is it, because there's no other even numbers that are prime numbers. So hopefully you had just 2 in that set. What's in A and in C? Well, A is all the even numbers and C is all the odd numbers. So there's nothing in A that's also in C. So there'll be nothing in that set. What about B and C then? So I can see that 3 is in both. I can see 5 is in both. 7, 11, 13, 17, and 19. And everything that's not in A, so if it's not in A, which are even numbers, then they're going to be, if it's not in A, then they're going to be the odd numbers, union C, which are the odd numbers. So it's going to contain all the odd numbers between 1 and 20 inclusive. So hopefully you came up with this list for A complement union C. Well done if you did. Okay, thanks for listening to today's lesson and video, and stay safe.